Now, let's try to solve this problem. Infrared spectra of three compounds are provided below. Each compound has one or more of the following functional groups: conjugated ketone, ester, amide, nitrile, and alkyne. Determine the functional groups in each compound and assign the major peaks above 1600 per centimeter. Here, this is a very prominent peak, strong peak, and look at this area. So very clearly, this peak is at 1685 per centimeter. So this peak is definitely because of a carbonyl group. Okay, now come here and at the 3000, you see that here, these are the aliphatic carbon-hydrogen stretching, but this can be a CH stretch because of a sp2 hybridized carbon, and sp2 hybridized carbon hydrogen bond stretching maybe. And then here we have this small peak. This may be because of a carbon-carbon double bond stretching. So we can say that this is perhaps this is a conjugated ketone. Okay, this B, look at this again. We see it's a very prominent peak here, prominent peak, definitely a carbonyl. What type of carbonyl? Maybe ester, or and here 3000. We don't have any peak here, all aliphatic, and so most probably this is an ester. Okay, this is an ester because this peak is a little bit higher than that of aldehydes and ketones, and so generally we say that this is the area where we should have a ester. Okay, now this compound, you can see this very characteristic feature of this spectrum, and you are having this very important peak here. Okay, the question is, what is it? Carbonyl group is there. So, but this carbonyl is at where? So this carbonyl is, you can say this is lower, that is not at 17, but about 1650 or 1640. And that is the area of a carbonyl of amide. And this doublet shows that maybe it is a NH2 group. And based on this, we can say that this is a primary amide. And here you can see that these are the aliphatic carbon-hydrogen stretching. So this is how you have to see the prominent peaks, and then based on those observations, you have to predict the functional groups. Okay. This is a simplified summary of IR stretching frequencies. Okay. And you can see carbon-carbon bond, carbon-oxygen bond, carbon-nitrogen bond. These are the, it's a big area, okay? And somewhere because of the other reasons, it can be anywhere. But this is the fingerprint region, and generally we do not come to this area. And then we have this area from 1600 to say 1800 something. And this is the area of carbon-carbon double bond, carbon-oxygen double bond, carbon-nitrogen double bond. And we know that whenever we have a carbon oxygen double bond, this is a very prominent absorption. And then this is the area where we can have carbon-carbon triple bond and carbon-nitrogen triple bond. This is the area, okay? Keep this in mind. And what about this area? Okay, and we have 3000, maybe 3015, or then mostly less than that. We have this carbon hydrogen stretching, and then we have broad hydrogen, this oxygen hydrogen stretching broad and strong absorption. And then we have this NH here, maybe in the form of a kind of one peak or a doublet type of doublet. So maybe primary or maybe secondary. And similarly, we know that based on the position and also the shape of these peaks, we then determine the functional groups present in that molecule. Okay, so this is a kind summary, and you can then go through it. Whatever we have studied is summarized here, and this is very useful that you have a look on this, and frequently you should go through it so that these things are kept in your mind. Okay, and we are now going to the end of this chapter. And here we have a solved example. I asked you to go through this solved example, and a unknown compound having this absorption, and similarly based on this other data, you have to find out the functional group present in this molecule and other structural features possibly that we can determine through IR. Okay, now let us have some compounds and their spectra, and keep this thing in mind that visual impact is very, very important, and IR spectrum is best interpreted through your eyes. Okay, look and identify the peaks, and then you will be able to tell us as many functional groups as you can. For example, uh, quickly we can have this observation. This peak is so prominent that we cannot miss it, and this is a peak that is showing a carbonyl. And here this 3000, keep always this in mind. And on the left you are having no peak, but on the right you are having peak. So this is the aliphatic region, and so what we are having is a carbonyl compound, and this is a important region of a aldehyde or ketone, but we do not have those peaks here which are characteristic of aldehyde. So most probably we can say this is a ketone, maybe, but may not be. But this is what we are. Okay, so other data is required, and so that we are able to determine its structure. Absence of peaks here and broad peak, absence of broad peak here, we can say that most probably it is a ketone. It is a ketone. Okay, what about this? What about this? Which is this peak? Yes, carbonyl. Which carbonyl? Most probably. Okay, so look at this value. So if you remember, this value is probably showing that this carbonyl is amide carbonyl. So to confirm this, we will have to look on this side. So there you can see a doublet in this region. Okay, this doublet in this region 3300, and this is showing that it is a primary amide. So this and this jointly can indicate, and we can infer based on this that this is our amide. Here, explanation is given that absorption at 1650 per centimeter is so intense that it probably indicates a carbonyl group. Okay, look at the word probably. It means whatever we are saying is a prediction. Whatever we are saying is the most probable inference that we are deriving from it. Okay, so carbonyl group in this low frequency suggests an amide. Mean it is a carbonyl, but it is not at 1710 or 1710 or 1685, etc. So it's low, mean it is most probably amide. Okay, very interesting, very interesting. And in the first glance, we notice this. Okay, so whenever we notice this is a carbon-nitrogen triple bond. And so this compound is most probably a nitrile. So this is your 3000 and no carbon-carbon double bond is indicated because we don't have any sp2 hybridized carbon hydrogen stretching. And here also we do not have any peak at 1600 or something. So no carbon-carbon double bond. So we can say that this is what? This is a nitrile. And this is mean that this compound is saturated. And so this is a very prominent and characteristic feature of nitrile carbon nitrogen triple bond. Okay, what about this? You can see this carbonyl, okay, 1685, and then you also see these peaks, and here you also have these absorptions. So what do these data say? This data. So it means carbonyl absorption at 1685 is about right for a conjugated ketone aldehyde or acid. So it means whenever a carboxylic acid or aldehyde group or ketonic carbonyls, they are in conjugation with a double bond. So this is the value. Okay, and amide would be lower. We know that amide has a little bit lower absorption, maybe 1600 uh, uh, 40 something like that. The absence of any NH is also not there. OH group is also not there, and we do not have CH aldehydic stretching also. So the carbon-carbon double bond is stretch is there 1599, and that indicates an aromatic ring. So confirmed by the unsaturated CH absorption above 300. Okay, and so we assume that this is uh, a, a ketone with conjugation of a aromatic ring. Okay, so this is your 300, and you have these peaks uh, showing a carbon hydrogen stretching. Okay, and similarly this one, and this is also a carbon carbon stretching. So based on this data, we can say that this is a ketonic group attached to a ring. Okay, what about this compound 5? This peak 1688, and then this is your 3000. Most peaks on this side. Okay, the broad OH stretch that spans most of the CH, mean it's broad region of a carboxylic acid. This acid is a solid, and its OH absorption is weaker than that of the liquid. Here, yeah, these are the carbon-carbon stretching absorption because of the aromatic carbon-carbon double bond. So this is again a carboxylic acid where the carbonyl group is attached with ring. So this is the most probable prediction that we can make. What about this? Again, a carbonyl and also having these peaks here, and this is a carbonyl at somewhat higher. So easily we can say that this is most probably an aldehyde. Whether this aldehyde is saturated or unsaturated, so you can see that we have the peaks on the right of the 3000, so it means it is saturated. Okay. Yeah, this compound, very important, interesting. You have this carbonyl and it is at this peak, and if you remember that this is a somewhat higher value, and we also do not have those characteristic peaks of aldehyde, no hydroxyl group, and so it is most probably an ester. And this peak at 16 is showing what? 16, this peak is showing a carbon-carbon double bond in the aromatic region. So we can say that this is an ester, and so we can have this compound that is the ester and having aromatic ring as well. So here are the compounds, and you can see this is your compound 7 having aromatic ring, and also this carbonyl. This carbonyl is not attached to the ring, otherwise its value would have been lower because of conjugation. And so these are the compounds, all the 7 compounds whose spectra we have just discussed. Okay, look at this spectrum. Go here, 3000, a peak here, that is indicates a carbon hydrogen stretching where the carbon is alkenic, sp2 hybridized. This is carbon hydrogen stretching where the carbon is sp3 hybridized. What about this? This is a peak, and it is in the region where a carbon-carbon double bond stretching up here. So overall, this is a simple spectrum having a aliphatic region and a alkene as well, where a carbon-carbon double bond, carbon-carbon double bond stretching, absorption, and this carbon-hydrogen stretching, where the carbon is sp2 hybridized. Look at this spectrum and carefully observe different values. Where are different peaks? Okay. This is very strong absorption, maybe carbonyl. Here you have these peaks, 2712, 2814, showing aldehydic carbon hydrogen stretching. Here the 3000 peaks are here. Okay, and 3000, if you see, you also have some absorption here in this side as well. And this peak is very prominent and very indicative. That is showing a carbon-carbon double bond stretching of an alkene. So we can conclude that if this is an aldehyde and this is a carbonyl group, and this is a carbon got double bond based on this, we can say that this is a aldehyde group which is in conjugation with the carbon-carbon double bond, because only an aldehyde group uh, in conjugation with carbon-carbon double bond can give us lower value of this. Otherwise, the value would have been 1720 or around that. Okay, so based on these facts, we can say that most probably this compound is an aldehyde, where the aldehyde group is in conjugation with a carbon-carbon double bond. Okay. Now this one, and you can see this broad absorption. You can also see this absorption here, but also here, this one carbon-carbon double bond, this carbon-oxygen double bond, and this hydroxyl group. So what is the most probable inference? It is a carboxylic acid where the carbonyl group, carbon oxygen double bond group, is in conjugation with a carbon carbon double bond. Okay, so this is what we can draw conclusion from here. Let's go to the next. Okay, observe this. Observe this. This is carbon hydrogen stretching. This is carbon carbon stretching. And this is a carbonyl group. So we can say that this substance has a carbonyl, and along with that we have aromatic ring as well. So this can be an ester, okay, and because it has very strong ketone would have 1710, etc. Only the esters have this much high, and when this hydroxyl group is absent, so most probably this is an ester.